Welcome to Code Jungle. In this video, we will discuss about one of the sorting techniques, that is bubble sort. Bubble sort is a technique where sorting is done by stepping through the array repeatedly. In each step, a pair of adjacent elements are compared and swapped if not in the desired order. The worst case and average complexity of bubble sort is big O of n square, where n is the number of elements being sorted. In this given video, we will consider the given array with values 4, 6, 3, 5, 1 and 2 as input, and the desired output is a sorted array with values 1, 2, 3, 4, 5 and 6. So now let's proceed ahead and check how it works. Given here is the array, and here our first job is to step through this array and traverse through it for n minus 1 times, where n is the total number of elements. So here in total we have 5 iterations because the total number of elements which we have is 6. Our second task is, during each traversal we will check if in a given pair of two adjacent elements, first one is greater than second or not. If yes, we will swap their values. For example, if 4 and 6 is given, and if 4 would have been greater than 6, we would have swapped it. By the end of all the traversals and swappings, we will see that the array is sorted. So now let's move to the first iteration. Here, to begin with, we will consider the second element of the array as jth element and first as j minus 1th element. Now we will check if element j is greater than element j minus 1. If no, we will simply swap and then we'll move ahead with the next set of j and j minus 1th element. Here 6, that is j, is greater than 4, that is j minus 1, hence there is no need of swap. So we move ahead. In the next step, 3, that is the next element of the array, becomes element j, and 6, that is the second element of the array, becomes j minus 1. So we basically simply move ahead for the next step. Here 3, that is j, is less than j minus 1, hence there is a need of swap. So we swap it. Next we will check for 5 and 6. Again 5 is less than 6 and hence we will swap it. Next we check for 1 and 6. Again 1 is less than 6 and hence we swap it. Next we will check for 2 and 6. Again 2 is less than 6, so there is a need of swap. So basically, when j is not greater than j minus 1, we swap it. And with this we complete our first iteration, and at the end of first iteration we see that the biggest element of this array sits at the end of the array. Now let's move to the next iteration. Here, while traversing through the array, instead of traversing through all the elements, we will do it for 5 elements. This rule will be applicable in all the iterations. That means every time iteration increases by 1, number of elements to be traversed decreases by 1. So over here, now 3 becomes j and 4 becomes j minus 1. As 3 is less than 4, hence there is a need of swap. Next, we will consider 5 and 4. As 5 is greater than 4, hence there is no need of swap. Next, we will consider 1 and 5. As 1 is less than 5, hence we swap it. Next, we will consider 2 and 5. As 2 is less than 5, hence again we will swap it. With this, we complete our second iteration, and at the end of second iteration, if you notice, the second largest element gets to sit at the second last position of the array. Now we begin our third iteration. Again, 4 becomes our element j and 3 becomes element j minus 1. As 4 is greater than 3, hence there is no need of swap. Next, we will go for 1 and 4. 1 is j and 4 is j minus 1. As 1 is less than 4, hence we swap it. Next, we will consider 2 and 4. Here again 2 is less than 4 and hence we swap it. And with this we complete our third iteration. And again at the end of the third iteration, if you notice, the third largest element gets to sit at the third last position of the array. Now let's move to the fourth iteration. Here now 1 becomes j and 3 becomes j minus 1. As 1 is less than 3, hence we swap it. Next, we go ahead with 2 and 3. Again, 2 is less than 3, hence we swap it. With this, we complete our fourth iteration, and if you see, at the end of the fourth iteration, the fourth largest element gets to sit at the fourth last position of the array. Next, we will go ahead with the fifth iteration. Here, 2 becomes the jth element and 1 becomes j minus 1 element. As 2 is greater than 1, hence there is no need of swap. And with this, we complete our fifth iteration as well. And by the end of the fifth iteration, that is the last iteration, we see that the array is sorted. That's all for this video. Link for the source code is given below in the description box.
If you like the video, don't forget to hit the like button, do comment, share and subscribe to the channel.
We will be back soon with more videos. Thanks for watching.